Hi, it's Mrs. Moret with help on today's assignment, Unit 3, Lesson 4 Practice Problems. In your textbook, pages 49 through 51, and you're just doing numbers 1 and 2 and 3A. So here we go. The scatter plot shows the number of times a player came to bat and the number of hits they had. So here's the scatter plot, here's the at-bats, and here's the hits. So the scatter plot includes a point at 318.80. Describe the meaning of this point in this situation. So the 318, since that's in the space of the X value, it's 318 at-bats. And likewise, the 80 is in the Y space, so it's the number of hits. So the point describes that a player had 318 at-bats and 80 of those at-bats were hits. All right. On number 2, we're looking at another scatter plot. This scatter plot shows the number of minutes people had to wait for service at a restaurant and the number of staff available at the time. So you can see that as the number of staff increases, that the wait time decreases, since you can see like this general going down trend, okay? So a line that models this data is given by the equation y equals negative 1.62x plus 18, where y represents the wait time and x represents the number of staff available. The slope of the line is negative 1.62. What does this mean in this situation, and is it realistic? So the negative 1.62 tells us that, and it's the wait time that's decreasing, right? So the wait time decreases. Okay, so since it's negative, it decreases. By how much? Oh, by 1.62. And these are in minutes. And that's as the number of staff increases by 1. Okay. And is that realistic? I would say yes, because the more people able to help you, the less time there will be to wait. All right, next it says the y-intercept is 0.18. What does that mean in the situation? So a y-intercept of 0.18 would mean if there were 0 staff, you'd have to wait 18 minutes. Now, is that realistic? I would say not realistic, because if there wasn't any staff, wouldn't you actually have to wait forever? I mean, if there's nobody there to help you, there wouldn't really be a limit on how long you'd have to wait. So I would say it's not realistic in this situation. All right, and then the last one is about a taxi driver. So a taxi driver records the time required to complete various trips and the distance for each trip. So here's the scatter plot, and it's got a line of best fit. And it says the best fit line is given by the equation y equals 0.467x plus 0.417, where y represents the distance in miles and x represents the time for the trip in minutes. Use the best fit line to estimate the distance So we're going to estimate the distance for a trip that takes 20 minutes, okay? So again, looking at the graph, we can say distance is the y value and time is the x value. So that tells me that we know 20 minutes is the x and we're solving for the y and we have this equation to use. So y equals 0.467 times 20 from here, and then plus 0.417. So I'm going to put that into my calculator. 0.467 times 20 plus 0.417 is, I would round that to 9.8. So the estimate, I would say, since this is about 9.8, I would say about 9.8 miles. And that is the end of your assignment. I hope that was helpful.